Hey students, here are your notes on lesson 2.5, similar figures. So first of all, similar figures are figures that have the same shape. Oops, let me get my pen going here. The same shape, but not necessarily the same size. So two figures are similar when corresponding side lengths are proportional and corresponding angles are congruent. So if you remember when we were talking about congruent shapes, the corresponding side lengths had to be congruent as well as the corresponding angles are congruent. But with similar shapes, the corresponding side lengths need to be proportional but not congruent. So when we look at example 1, we want to see which rectangle is similar to rectangle A. So we can do that by setting up a proportion. So let's first compare A and B. If we have the red sides here, the red sides have a side length or a ratio of 2 to 3, and the blue sides have a ratio of 6 to 6. They're the same. So that does not set up a proportion. But when we compare rectangle A with rectangle C, we see that the red sides have a ratio of 2 to 3, and the blue sides have a ratio of 4 to 6, and that is proportional, right? 2 over 3 is the same thing as 4 over 6. We can multiply 2 times 2 to get 4. We can multiply 3 times 2 to get 6. So A and C are similar. Okay, so let's go ahead and look at this next example. We're told that the triangles are similar, and we're going to use that information to find x. So we can see as we're looking at these similar triangles that the corresponding sides would be this 6-meter side with this 9-meter side. So that's a ratio of 6 to 9, or we could write that as a ratio of 2 to 3. And that's going to equal the ratio of 8 to x. Okay, we could write it like this too. It's just going to be a little bit easier to solve since we've simplified our ratio to 2 to 3. We can see that we're multiplying by 4 and that x equals 12. So this is 12 meters. If I have a proportion set up like up here above, I could use cross products to solve this. I could say 6 times x equals 72, which is 8 times 9. I can divide by 6, and I can also get 12 that way. So either of those proportions would help me solve for x. Okay, our next example here is a real-life application. Sorry, that's a little bit sloppy. I had to write over what I had there. So we have an artist draws a replica of a painting that is on the Berlin Wall. So here's the painting, this larger figure, and then here is our replica, which is obviously a little bit smaller. So the painting includes a red trapezoid, and the shorter base of the similar trapezoid in the replica is 3.75 inches. So we know that trapezoids have two bases that are parallel. Here's the shorter of the two bases. So we want to know what is the height of the trapezoid in the replica. So we're looking for this dimension right here. So the shorter base in the painting, in the trapezoid in the painting, is 15 inches. So I can say that the ratio of the replica to the actual painting is 3.75 to 15. Okay, and then we can use that same ratio to say that h to 12 will be proportional. So here we have this ratio of 3.75 to 15 and the ratio h to 12, and we're going to solve that proportion for h. So we can do that using cross products. So 15 times h is 15h, and that's going to equal 12 times 3.75, which is 45. And then we're going to solve for h by dividing by 15, and we get h equals 3 inches. So this height of the trapezoid and the replica is just a little bit smaller than the smaller base, which is also true when we look at 12 compared to 15. Okay, so go ahead and try a few on your own, writing those proportions, and don't forget to look back at the examples if you need them.